Today, we're going to be learning the substitution method, part 2. Now, I hope you've already checked your homework from last night, because I wasn't really planning on going over that. That's why I posted it for you to check on your own. I just thought that would be painful to listen to me go through all those problems. By the way, I only expected to assign you half of those. I apologize for how long that was. I know, a little late now, huh? I'll make up for it, I promise. Here's our first example for today, and what I want you to notice is that nothing in this problem is solved for y or solved for x. Now what this means is that we have two options for how we can solve this equation. One thing we can do is we can start by adding 2x to both sides, give me y equals 7 plus 2x, and then I can take that and put it where the y is in the other equation, giving us x plus 2 times 7 plus 2x, that's an x, equals 4. A little crowded over there, sorry. That gives us x plus 14 plus 4x equals 4. Notice I used the distributive property there. And of course we should simplify before we go any further, turning that into 14 plus 5x equals 4, and then subtracting 14. We get 5x equals negative 10, which means that x is negative 2. Now, conveniently, and this is going to be something that we see all the time when we're using the substitution method, is right here I have an equation that's solved for y. I already know x, so let's just substitute in there to find y. Y is going to equal 7 plus 2 times negative 2, which is 7 plus negative 4, or 3. So I'm pretty sure the solution is negative 2, 3. We used a derivation of this equation to figure out what 3 is. So I'm pretty confident that this is going to work great there, and you can see it does. 3 minus 2 times negative 2 would be 3 minus negative 4. Yes, it does equal 7. But really, the trick is did it work here? And it does, because x is negative 2. 2 times 3 is 6. Negative 2 plus 6 does equal 4. Now what I'd like to do is I'd like to demonstrate this process a second time, but solving for x. This time I'm going to subtract 2y, giving me x equals 4 minus 2y. And now I'm going to take that and put it where the x is in the other equation. This gives me y minus 2 times 4 minus 2y equals 7, which is y minus 8 plus 4y equals 7, which is 5y minus 8 equals 7. Adding 8, we get 5y is 15, which means that y is 3. A reminder, that's what we got the first time we did it. X is 4 minus 2 times 3, so x is going to be 4 minus 6, which is negative 2. But again, that's actually x is negative 2, y is 3. We've already checked that answer. It's correct. Here's a new problem. One method really screams out here is this is the way you want to do it. Why don't you do that right now? Hit pause. I'll wait. Hey, you're back. So I'm guessing what you did is you probably added 2y to both sides because you saw that this was the only variable that didn't have a coefficient. Adding 2y to both sides, you get x equals 13 plus 2y. And you take that and you stick it where the x is, and you get 3 times 13 plus 2y plus that 2y equals 7. 3 times 13 is 39. 3 times 2y is 6y plus 2y equals 7. Subtracting 39, we get, oh, I didn't simplify first, forgive me. Those simplify to be 8y equals negative 32. And then we divide by 8, and we get y is negative 4. So x is going to equal 13 plus 2 times negative 4. 13 plus negative 8 is 5. So we're pretty sure the solution is 5, negative 4. Let's check that really quick. 2 times negative 4 would be negative 8. 5 minus negative 8, yep, that's 13. And 3 times 5 is 15. 2 times negative 4 is negative 8. 15 plus negative 8 does equal 7. Yes, that is the solution. Now what I want to show you is I want to show you something cool that we could have done instead. Maybe you see it now. I'd be surprised, but it could happen. You might notice that I have a 2y in both equations. I'm going to start by subtracting x from both sides. It gives me negative 2y equals 13 minus x. And then I'm going to change the sign of everything, giving me 2y equals negative 13 plus x. 2y equals this. So I'm not going to replace y with this. I'm going to replace 2y with this. This becomes 3x plus, instead of writing 2y, I'm going to write negative 13 plus x equals 7. Again, I didn't replace y, I replaced 2y with that. This gives me 4x plus negative 13 equals 7. Adding 13, we get 4x is 20. Or x is 5. Looky here. The downside here is I don't have any equation that's solved for y. I've only got an equation that's solved for 2y. But okay, what is negative 13 plus 5? Well, it's negative 8. And if 2y equals negative 8, then y equals negative 4. And again, for those of you with short memories, you can see that was our original solution, was 5, negative 4. So that's an option. You can do that. It's kind of freaky weird. There might, at some point in this unit, come a time where that's the best way to solve something like that. But there are always going to be options. That's all. Enjoy your homework. We'll talk to you tomorrow. Bye-bye.